Welcome. This presentation is a discussion on calculating the revolutions per minute for a given surface feet a minute. Before we get started here, let's just look at a few terms that you'll hear me use in this presentation. First one is RPM, revolutions per minute. Second one is SFM, surface feet per minute. Third one is pi. It's the ratio of the circumference of a circle to its diameter. That's all we need to know about that. The next one is CSM, or constant surface speed per minute. Then we have NC, numerical control. That's a machine tool that's where the axes are controlled electronically. Then we have CNC, which is a computer-assisted numerical control. DIA is an acronym for diameter. Then we have OD, outside diameter, and ID, inside diameter. So whether you're machining with a lathe, a mill, a drill, or some other rotary cutting tool operation, the operator should be cognizant of what RPM to use. Most manual machines will only allow the operator to select an RPM close to, but not exactly what is needed. In the past 43 years, I have maybe changed the belts on my drill press to control the speed 3 times. NC and CNC machines would give the user infinite RPM control. The first piece of the equation is surface feet per minute. Surface feet per minute is the distance that the cutting tool land, the outer diameter of a milling cutter, or the tip of a turning or boring tool moves along the surface of the workpiece. The second piece of the equation is the diameter. The diameter is a major factor in calculating the RPM, as the larger the diameter, the slower the RPM. The smaller the diameter, the faster the RPM. Back in the day, the cutting tool salesman would give away these cutting speed calculators. They might be cardboard or plastic. This is a Kennametal. It's cardboard. Got 3 layers with a center layer that's kind of sandwiched in between. And if we go down to the bottom area here, the yellow area, we would slide that back and forth and set our diameter. So here we're looking at somewhere around 6 3/4 inch diameter. And then at the very bottom, we go over and we find a surface feet per minute. And if we come over here and find, let's say, 200 surface feet a minute, we're looking at something in the neighborhood of about 120, 115 or so RPM. Today, people would, most likely use their calculator or an app on their smartphone. Most cutting tool and some machine tool manufacturers passed these out, and most machine operators had one in their toolboxes. Calculators before smartphones. So, with a known surface feet per minute and a cutting diameter, we calculate the RPM as follows. The RPM is equal to 12 times the surface feet per minute divided by 12 times the diameter. We can make this a simpler equation by taking 12 and pi and make a constant out of it. So 12 divided by pi gives us a value of 3.82. A friend of mine who used to teach shop high school class told me that he used to just tell his students to use 4. So RPM is equal to 3.82 times the surface feet per minute, and then you divide that by the diameter. Here's an example. 3.82 times 100 surface feet a minute divided by 0.5 for a half-inch diameter results in 770 RPM. Okay, so here's an example graphically. For a turning operation, our part here is a 6-inch diameter. We have a carbide cutting tool cutting from right to left. It's an OD turning operation on a 6-inch diameter at 300 surface feet per minute. The equation is 3.82 times 300 surface feet per minute divided by the 6-inch diameter, resulting in 191 RPM. The second example right here, and these are given for repetition, so it kind of drills in, the equation for calculating this stuff. So our part here, the inside diameter is a 3-inch. We have a carbide boring bar cutting from right to left. So it's an ID boring operation on a 3-inch diameter at 300 surface feet per minute. The equation's 3.82, our constant, times 300, and we divide that by the diameter, 3. We come up with 382 as the RPM. Our third and last example right here is going to be a drilling operation, and it will be for a 1/2-inch diameter hole at 100 surface feet per minute. Unlike the two previous examples, turning and boring with a carbide cutting tool, this drill is just a high-speed steel drill bit, so that the surface feet a minute is much lower, 100. So our equation is 3.82 times 100 surface feet per minute, and that's divided by 0.5, the diameter of the drill. The resulting RPM value is 764. So I hope you found this video helpful and interesting. If you did, please click the like, subscribe, and share it with somebody. Thank you.